What if I told you that your favorite childhood toy isn't the same toy you remember, even though it's sitting right there in your closet? Imagine you have a wooden rocking horse that your grandfather built for you. Over the years, you've replaced the worn saddle, swapped out the broken rockers, and even changed the head when it cracked. Every single piece has been replaced, yet somehow, it's still your grandfather's rocking horse. But wait, what if someone collected all those original pieces you threw away and rebuilt the horse exactly as it was? Now, which one is the real rocking horse? The one you've been maintaining, or the one rebuilt from original parts? This is the ship of Theseus paradox, and it's about to unravel everything you thought you knew about identity itself. It seems more complicated than separating two pieces of spaghetti that are stuck together, but it's actually surprisingly simple. Welcome to the strange world of paradoxes, those delicious mental knots that tie our brains in loops and leave us questioning reality itself. A paradox isn't just a puzzle or a riddle. It's something much more powerful and unsettling. It's a statement or scenario that seems logically sound but leads to a contradiction, or appears obviously false but reveals hidden truth. Think of paradoxes as stress tests for the human mind. They push our mental models to their breaking point. They expose the hidden assumptions we didn't even know we were making. But here's what makes paradoxes truly fascinating. They're not just philosophical party tricks. These brain-bending puzzles have been the secret engines driving human progress for thousands of years. Every time we encounter a paradox that breaks our understanding, we're forced to build better tools for thinking. The ancient Greeks used them to sharpen logic. Medieval scholars used them to explore the nature of God and infinity. Modern scientists use them to peer into the quantum realm and the far reaches of space-time. Today, we're going on a curated tour through three different kingdoms of paradoxes, each one revealing something profound about the limits and possibilities of human thought. We'll start in the realm of identity and change, where we'll discover that nothing stays the same, including ourselves. Then we'll venture into the twisted landscape of logic and language, where words themselves become weapons that can destroy meaning. Finally, we'll brave the impossible territories of infinity and contradiction, where our everyday intuitions completely break down. By the end of this journey, you'll see that paradoxes aren't glitches in reality. They're the very tools that help us transcend the boundaries of what we thought was possible. Let's return to that rocking horse, because it holds the key to one of humanity's most enduring questions: what makes something the same thing over time? The ship of Theseus paradox, first posed by the ancient Greek philosopher Plutarch, goes like this. Theseus, the legendary hero of Athens, returns from his adventures, and the Athenians decide to preserve his ship as a monument. But wood rots, sails tear, and metal corrodes. So piece by piece, they replace every component with identical materials. After decades, not a single original plank, rope, or nail remains. Here's where your brain starts to hurt. If every physical piece has been replaced, is it still Theseus's ship? Your gut says yes, it looks the same, serves the same purpose, sits in the same place. It has continuity. But then the philosopher Thomas Hobbes added a twist that makes everything worse. What if someone had collected all those discarded original pieces and reassembled them into a ship? Now you have two ships, both with equal claim to being the real ship of Theseus. Think of it like your smartphone. You probably consider it the same phone even though you've updated the software dozens of times. Replace the screen protector, maybe even swap the battery. The apps have changed, the photos are different, even some of the internal components have been refreshed through updates. Yet it's still your phone because of continuity of function and ownership. But if someone took your old cracked screen, your original battery, and your first installed apps and somehow rebuilt them into a working device, which would be your real phone. This isn't just about ships and phones, it's about you. Right now, as you're listening to this, the vast majority of atoms in your body are different from the ones that were there 7 years ago. Your cells have died and been replaced. Your thoughts have evolved. Your memories have been altered every time you've recalled them. The person you were as a child shares almost no physical matter with who you are today. So what makes you, you? The ship of Theseus paradox forces us to confront a fundamental question about identity. Is it about the physical stuff something is made of, or the pattern and continuity of its existence? This question becomes even more crucial as we enter an age of digital consciousness, genetic engineering, and artificial intelligence. If we can copy a mind, restore damaged brains, or transfer consciousness, we'll need better answers than the ancient Greeks could provide. But there's another paradox lurking in the realm of identity that's even more unsettling because it attacks the very idea of clear boundaries. The Sorites Paradox, named after the Greek word for heap, starts with a simple question: how many grains of sand make a heap? Imagine you have a million grains of sand. Clearly a heap. Now remove one grain. Still a heap, obviously. Remove another grain. Still a heap. Keep going. At what exact point does it stop being a heap? After you remove the 500,000th grain, the 100th, the 10th? The uncomfortable truth is that there's no magic number where a heap suddenly becomes a non-heap. Yet somehow, we go from definitely having a heap to definitely not having one. This paradox reveals something disturbing about the way we categorize the world. Most of the boundaries we rely on, rich versus poor, tall versus short, healthy versus sick, even alive versus dead, are actually fuzzy zones rather than sharp lines. Consider baldness. No one would argue that a person with 100,000 hairs is bald, and no one would argue that a person with 0 hairs isn't bald. But somewhere between those extremes lies a gray zone where the answer becomes uncomfortably unclear. The Sorites Paradox shows us that change often happens so gradually that it becomes invisible, even though the cumulative effect is dramatic. This has profound implications for how we understand everything from climate change to personal growth to the evolution of species. Major transformations rarely happen in sudden leaps. They accumulate through countless tiny steps that individually seem insignificant. Now let's venture into even stranger territory, where language itself becomes the enemy of meaning. In 1901, mathematician Bertrand Russell discovered a paradox so devastating that it shook the foundations of mathematics and logic. But to understand Russell's paradox, let's start with something simpler and more visceral: the liar paradox. Imagine you encounter a statement that says, "This statement is false." Take a moment to think about it. If the statement is true, then it's false because that's what it claims to be. But if it's false, then it must be true because it's correctly describing itself as false. Your brain just got caught in an infinite loop, and there's no way out. This isn't a flaw in your thinking, it's a fundamental problem with self-reference in language itself. Think of it like a computer program that says, "Ignore this command." If the computer obeys the command, it's disobeying it. If it disobeys the command, it's obeying it. The program crashes because it's been given logically contradictory instructions. The liar paradox does the same thing to human reasoning. But Russell took this idea and weaponized it against mathematics itself. He considered the set of all sets that do not contain themselves. Most sets fall into this category. The set of all apples doesn't contain itself because it's not an apple, it's a collection. But what about the set of all sets that don't contain themselves? If it contains itself, then it doesn't belong in the category, so it can't contain itself. But if it doesn't contain itself, then it belongs in the category, so it must contain itself. Russell had discovered that the very foundation of mathematical logic was built on quicksand. Russell made his paradox more accessible through the famous barber paradox. In a town, there's a barber who shaves all and only those men who do not shave themselves. The question is, who shaves the barber? If he shaves himself, then he's someone who shaves himself, which means he shouldn't be shaved by the barber. But if he doesn't shave himself, then he's someone who doesn't shave himself, which means the barber should shave him. But he is the barber. This might seem like a clever word game, but it reveals something profound about the limits of logical systems. Self-reference, the ability to talk about ourselves, is one of the most powerful features of human consciousness. It's what allows us to be self-aware, to reflect on our own thoughts, to improve our own thinking, but it also opens the door to these devastating logical contradictions. Consider how this plays out in real life. We create rules and then debate whether those rules apply to themselves. We build institutions to govern institutions. We use our minds to study our minds. Each of these situations contains the seeds of paradox, and navigating them requires a kind of intellectual humility that accepts the inherent limitations of any logical system. Our final destination is perhaps the most mind-bending realm of all, the paradoxes that arise when we try to grapple with infinity and contradiction. These paradoxes don't just challenge our logic, they obliterate our intuitions about reality itself. Let's check into Hilbert's Grand Hotel, a thought experiment proposed by mathematician David Hilbert. Imagine a hotel with infinitely many rooms, numbered 1, 2, 3, and so on forever. Every room is occupied. The hotel is completely full. Now, a new guest arrives and wants a room. In a normal hotel, you'd have to turn them away. But this is an infinite hotel, so the manager has a clever solution. He asks every guest to move to the room number that's one higher than their current room. The guest in room 1 moves to room 2. The guest in room 2 moves to room 3, and so on. This frees up room 1 for the new guest. The hotel was completely full, but somehow accommodated another guest without anyone leaving. But wait, it gets more bizarre. What if an infinitely large bus arrives? carrying infinitely many new guests. No problem, says the manager. He asks all current guests to move to the room number that's double their current room number. Guest 1 goes to room 2. Guest 2 goes to room 4. Guest 3 goes to room 6, and so on. This frees up all the odd-numbered rooms, infinitely many of them, for the infinitely many new guests. Hilbert's hotel reveals that infinity doesn't behave like normal numbers. With infinity, you can add, subtract, and even multiply by infinity and still have infinity. It breaks our fundamental intuitions about quantity and space. This isn't just a mathematical curiosity. These insights about infinity have been crucial for understanding everything from the geometry of spacetime to the behavior of quantum particles. But perhaps no paradox has been more influential than Zeno's paradox of Achilles and the tortoise, proposed by the ancient Greek philosopher Zeno of Elea around 450 BCE. The setup is simple. The swift-footed hero Achilles races a tortoise, but gives the tortoise a head start. Zeno argued that Achilles can never overtake the tortoise, and his reasoning seems airtight. Here's the logic. Before Achilles can overtake the tortoise, he must first reach the point where the tortoise started. But by the time he reaches that point, the tortoise has moved a little further ahead. Now Achilles must reach this new point, but again, by the time he gets there, the tortoise has moved further still. This process repeats infinitely. Achilles gets closer and closer, but he must always complete an infinite number of tasks before he can overtake the tortoise. Of course, we know from experience that faster runners do overtake slower ones. But Zeno's paradox remained unsolved for over 2,000 years because it exposed a fundamental problem with how we think about space-time and motion. The paradox wasn't resolved until mathematicians developed sophisticated tools for dealing with infinite series and limits. What seemed like a simple problem about a race actually required revolutionary insights about the nature of infinity and continuity. These aren't just ancient puzzles gathering dust in philosophy textbooks. The paradoxes we've explored are the secret engines that have driven some of humanity's greatest intellectual achievements. Every time we encounter a paradox that breaks our understanding, we're forced to build better mental tools, and those tools often revolutionize entire fields of knowledge. Take quantum physics. When scientists discovered that particles could exist in multiple states simultaneously until observed, it seemed paradoxical. Schrödinger's famous cat thought experiment highlighted this weirdness. A cat in a box could be both alive and dead until someone opened the box to check. This quantum paradox didn't just challenge our understanding. It led to the development of technologies like lasers, MRI machines, and quantum computers that are reshaping our world. In computer science, those self-reference paradoxes we explored aren't just philosophical curiosities, they're fundamental limitations that define what computers can and cannot do. The famous halting problem shows that there are mathematical questions that no computer program can ever answer, no matter how powerful. Understanding these paradoxical limits has been crucial for developing programming languages, artificial intelligence, and cybersecurity protocols. Even in your daily life, you're constantly navigating paradoxical situations without realizing it. When you update your social media profile, you're grappling with the ship of Theseus paradox. Are you the same person you were last year? When you debate whether something is too expensive or too risky, you're encountering the fuzzy boundaries revealed by the Sorites Paradox. When you make rules for yourself and then debate whether to follow them, you're wrestling with the same self-reference problems that stumped Russell and Hilbert. The most successful leaders, scientists, and innovators aren't those who avoid paradoxes. They're those who have learned to dance with them. They understand that contradictions and impossibilities aren't roadblocks, but invitations to think more deeply and creatively. So what have we learned from our journey through these three kingdoms of paradox? The ship of Theseus taught us that identity isn't about the physical pieces, but about continuity and pattern. The Sorites paradox revealed that most of our categories are fuzzy zones rather than sharp boundaries. The liar paradox showed us that self-reference can break logic itself. Hilbert's hotel demonstrated that infinity transforms our understanding of quantity and space. And Zeno's paradox proved that even simple motion requires sophisticated mathematical tools to understand. But the deeper lesson is this: paradoxes aren't errors in reality or failures of human thinking. They're the stress tests that reveal the hidden assumptions and limitations in our mental models. Each paradox we encounter is an invitation to expand the boundaries of what we thought was possible. They force us to build better tools for thinking, more sophisticated mathematical systems, and more nuanced ways of understanding reality. The greatest advances in human knowledge have almost always begun with someone taking a paradox seriously instead of dismissing it. When ancient mathematicians couldn't accept that the square root of 2 was both a number and not expressible as a fraction, they developed irrational numbers, When physicists couldn't reconcile the wave and particle nature of light, they developed quantum mechanics. When logicians couldn't resolve Russell's paradox, they developed more sophisticated foundations for mathematics. The paradoxes that seem most impossible today, consciousness emerging from unconscious matter, free will existing in a deterministic universe, finite beings comprehending infinity, may well be the launch pads for tomorrow's revolutionary insights. In a universe full of mysteries, paradoxes aren't the problems we need to solve. They're the treasure maps pointing toward the next great expansion of human understanding. So here's my question for you. Which of these paradoxes changed how you think about something in your own life? Was it the ship of Theseus making you reconsider your own identity? Or maybe Hilbert's hotel breaking your intuitions about infinity? Drop a comment and let me know which paradox hit you the hardest. And if you enjoyed wrestling with these mental pretzels, subscribe for more deep dives into the ideas that shape our understanding of reality. And that's how spaghetti untangles another mystery of the universe. See you in the next episode.